Hello guys, our 2.4 notes are over secants and cosecants graph. By now you should be able to graph sine, cosine, tangent, and cotangents. Secants and cosecants are very related to sine and cosine. Now, you should know that secant is the brother of cosine as we mentioned in class, and cosecant is the brother of sine. So, in order for you to graph secant, you need to know that it's related to cosine. Let's start by filling in this table. I'll use once again my calculator, although this is a non-calculator unit. On a calculator, to write secant, since the calculator does not have a button for secant, you would write 1 over the cosine of x. Make sure your calculator is in degrees because we have working with degree values, and make sure your table sets start at negative 270 and it goes every 30 degrees. So this is what you will see on your table. On your table, you will have negative 270, you will have an error, just like we did on our tangent graph. Wherever it says error, that tells me that we have an asymptote. And not only that, instead of error, you should write undefined. So if I were to write exactly on my worksheet, here I will write undefined. I will have my negative 2 here. I will have my negative 1.16. And my next undefined will be at negative 90. And I will have another one at 90. And the last one will be at 270. Now I expect you to fill out this whole box. Here it says plot the graph of y equal cosine x on the given set of axes. Actually, for cosine x, I don't expect you to plot it in because I expect you to know already how the graph will look like. So let's go ahead and graph our cosine x on this. Cosine goes through the point 0,1, excuse me. So since we're graphing cosine, it should go through this one for cosine of 0. Cosine of 90 on the other hand is 0. It should go through this point. You should know this very well, especially after doing your spaghetti project. So here's the first bump. The second one, we go all the way to here. Then if we go all the way to here, so it will be as follow. In this one, the same thing will happen. If we go to here, all right, there's few highlights. Some points that are called very important points are the highest, the lowest, and the middle points. I'm highlighting them or making it darker in blue. Now, once you complete with your cosine, because we're dealing with secant, wherever it's touching the axis, keep in mind, secant is equal to 1 over cosine. Wherever it's touching the axis, that means the cosine is 0. Since we're dividing by the cosine, we do not want it to be equal to 0. That's exactly where you will have your asymptote. Everywhere where it's intersecting the x-axis, that's an asymptote. And your secant function are just u or parabolas that will be going on your graph. Meaning, wherever you have a bump down, this is how your secant function will look in this specific area. In this one, it will look like this. And this one, it will look like this. By the way, this is not 2 complete cycle. To get 2 complete cycle, I need 3 more units here. I will need to have, since this one will be going up like this for my cosine, I will have this portion. And let's do the same thing on the other side since we ran out of room. If I have 1, 2, 3. All I will have on this side, because it just came down, the cosine function will be looking like this. So my other portion will be like this. That will be 2 complete cycles. This and this forms 1 cycle. this and these two halves will form the second cycle. Let's do the same thing now for our cosecant graph. Remember, cosecant is 1 over sine of x. So we will start by graphing the sine of x, put the asymptote wherever the sine is equal to 0, and graph our use. Sine goes through the 0, 0 for sure. Sine of 90 is 1, and then 180 is 0, 270 is -1, 90 here is at -1, -90 at -1, 180 should be at the origin, 270 should be at 1. I'll go ahead and graph this, and it will look like this. Alright, once you graph it, you can now graph your asymptote, knowing that the first one is again at the origin because it's going through 0, 0. Next one is here. We have one here as well. We will have one somewhere down here and one also somewhere down here. And to be exact, it will be 3 units away since we're counting by 3s here. So that will be 1, 2, 3. 1, 2, 3. Now to graph our function, it will look like this. The first one will be a u like this. And this is our cosecant function. And that will be exactly 2 complete cycles. So the period here will be from this point to this point. I would love to talk about domain and range, but we will going to do it at a specific example. Actually, we will do it now. What are the domain and range of y equals secant x and y equals cosecant x? Let's start with the domain. The domain will be all over. It will not be exactly all real numbers. Let's start now with cosecant of x. For cosecant of x, the domain is all real numbers as long as x is not different, it's not equal to plus or minus 180n. And the range will be all real numbers such that, let's not include an interval. Let's just write it the interval notation. For the range, I will say it is from -infinity to -1, -1 being included, union, I start back at 1 with a bracket, of course, till infinity. That's for the cosecant. If I do the same thing for the secant, the domain now will be all real numbers such that x is not equal to 90 degrees plus or minus 180. And keep in mind, you can write this in radians as well. And the range will be from -infinity to -1 with a bracket, union 1 till infinity, bracket also at 1. All right, the graph of y equals secant of x and y equals cosecant of x have something in common. The common thing among those two is the fact that they are both U-shapes, but the difference between them is the fact that they belong to 2 different families. The secant is with the cosine and the cosecant is with the sine. So to graph this, you will start by graphing the cosine or the sine function, and wherever it crosses the x-axis, that's where you have your asymptote, because that's where you will have the denominator. The denominator should not be equal to 0. Now, the last step is to draw, of course, the U-shape of the high and low points of y equal cosine x or sine x. Well, we have one example here for us to draw. Whenever you have a function such as this, it says cosecant here. Do not stress over the fact that it's a cosecant function. Instead of that, you need to graph yours, replace it with sine if needed, because cosecant is sine related. Now, if it was a sine function, let's study it the same way you have studied it. The first thing is your amplitude. So I will say my amplitude is 12. After my amplitude, I know that, let's find the period. The period here will be, since I see pi, this is with an x, we know it's in radian. The period of a sine will be 2 pi over 6. And if you do 2 pi over 6, you should end up with 12. The critical point is 12 over 4. And if you divide 12 by 4, you end up with 3. Since it's a sine, we know we start in the middle, going up because it's positive. The shift, we will have 5 units up, and we will have 7 units to the left. Let's go ahead and try to graph this function. I will start by graphing my axis. Because I will go 5 units up and 7 to the left, I will graph my axis kind of low and give myself some room to go 7 units to the left. And the critical point is 3. Now, let's start by graphing our 5 units up. 5 units up would be somewhere here. From the 5 units up, the amp is 12. Oh, let me fix this real quick. Since the amplitude is 12, I will go ahead and count from 5 to 12. 12 units after will give me 17. Assume it's here. And 12 units below 5, that will give me -7. So I have 17 there, and I have -7. All right, let's keep going. If I decide to now figure out where our shift is, we will know that it's 7 units to the left. So let's move it 7 units to the left. I would put 7 units to the left. Let's say it's here. The reason I'm putting a little far, because my critical point is 3. So 7 units to the left will be here at -7. After -7, I will have -4. After -4, I will have -1. After -1, I will have 2. After 2, 5, 8, 11, and 14. By the way, sorry about the bell. Now you can actually go ahead and graph your sine function, knowing that you start in the middle. -7 should be in the middle. So I have a point here at -7. That will be middle. After middle, going up, I'll have up, then middle, then down. Down will be somewhere here. Then middle, then up, then middle, down, and so on. Wherever is on the axis, that's where I will graph my asymptote. So I will have an asymptote here because it's touching the axis. I will have one here. I have one here and here. So now the only points left will be the ups and down. If it's high up here, by the way, I can always graph my sine function. My sine function will be like this, and I'm making it a dotted line. You don't have to graph it if you know already what you're doing. And you will be graphing the U's here. Here's my first U shape, second U shape, third U shape. That's not enough. This one will be 1, so I needed another one here to make this, and definitely have an extra asymptote at this point. And do not forget to put your arrows. I have arrows here, 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 and here. Come prepared. We will have a lot of graph for you in class.